Okay.
Yes.
Okay. Thanks for your introduction. My name is Yang. Today I'm going to give my latest study among the bio-inspired method for rock carving and antique pottery restoration. Okay. There will be 4 parts in my presentation. First is about the background. I think Dr. Zhang gave a lot of on the theory of the bio-cementation of the micro-induced KSI precipitation, the technology. Okay, I just quickly go through it as we are little beyond our schedule. First, we see the MICB. We use urea producing bacteria to hydrolyze urea to generate ammonia and carbonate. The carbonate then react with the Ca ions to get the Ca carbonate precipitation. There will be generally 3 outcomes of the MICB. First is to improve the shear strength. The second is reduce the permeability. The final, which can increase the pH among the environment. There are some potential application of MICB technique. For example, the road stabilization, erosion control, dike stability, and liquefaction prevention. I think this the last picture is the same as Dr. Zhang. There are several advantages of MICB technique. It's first is we can produce the bio-cement in ambient temperature. We require less energy to produce. The second is the bio-grout has much lower viscosity, which like water, we can just like spray or inject. Third is the bio-cement doesn't need heavy machine. As we said before, we can just spray instead of like a mixing machine. The fourth one, the bonding strength between the calcium carbonate among the sand grain or the aggregate is much stronger than that between the cement. The last one is the bio-cement, the bacteria we use is non-pathogen one and environmentally friendly. Okay. Other than those advantages, there are also some limitation of MICB. The first is the most important one, I think, the high cost. Okay, because we need a urea, we need the calcium carbonate, and we need a urea, and we need the calcium source. Also, we need a repetitive treatment to get a satisfied strength. The third is non-uniformity. I think it's very hard to treat it uniform. Then we got some new technology, but it's still some obstacle. Okay, the last one is maybe a needle ammonia smell. Okay, now I move to my prospective application on cultural genetics using our bio-cement. The first big is anchor wall. They got destroyed by the erosion, corrosion, like the salt attack or the acid erosion. The second one is from my hometown, the dark rock cup. They got the rock cutting got weathered and damaged. The last is unearthed pottery. Okay, as they have been buried in the earth for like a very long time, so it got broken and fragmentary. Okay, the scope of my work is to develop inorganic, strong weather resistance and high compatibility materials for historical relics restoration. There are some specific requirements for historical relics restoration. The first requires inorganic to avoid any aging problem. Okay, the second one is non-toxic. If we are doing repair work, if it's toxic, okay, it's harmful to our body. The second one is compatibility. Okay, we need it to well fit with our original one. The fourth one is chromatic aberration. We can say in another word, it's just the color difference. Okay, we want it fit each other more comfortably. Okay, without a big difference. The fifth one is high strength but lower than in situ strength, which means we needed the strength as much as high but close to the original sample instead of higher than that. Because this is for like historical relics. If we got further damage, okay, they will damage in the new one instead of the old one. Okay, that's their specific requirement. The sixth one is stronger resistance because they may like This are usually in nature. Okay, we need to resist the weather, like the raining or the sandstorm or whatever. Okay, the last one is a stronger biological resistance. There are many rock carving grow fungi. Okay, this like some fungi can generate acid, then get destroy the rock carving. Okay, this is my second part is about the microbial reinforcement and repair method of sandstone grotto in humid environment. I quickly go through this. Okay, this is the mechanism of carbonation process. We use the reactive mechanism to get a carbonate, then to form the hydrated mechanism carbonate. This is use conventionally use the CO2. However, we convert this to our biocarbonation process. We use our bio method to generate CO2. Then we got the same products. Okay, I just quickly go through this because I think you guys may not interested about this data. Okay, just one thing. Okay, the strength or is highly related to the HMC amount. We can say this is my formula. Okay, I just want to show you this is optimal one. This. Okay, we through the microstructure analysis, we can say the hydrated product is generally hydromagnesite and nesquihonite. This is the same as the carbonation method use a conventional CO2. Okay, now move to my study. Okay, the restoration of sandstone rock carving using biocarbonation method. First, we get the biocarbonation formula. It's from the previous study. Okay, plus the sandstone powder. First we get the sandstone and crush into powder. Then we mix my formula like we have urea, we have the bacteria and reactive mechanism and plus the sandstone powder. Then we form another sample. Use this to generate we call it repair mortar. Then we do the restoration. We can see the sandstone sample and the biocarbonated sample is we got a very similar, except like the color difference. You can see in your eye. I don't think you can see a big difference. Also, the strength is lower than the original one. They satisfy this, and also this one have a greater weather resistance. Okay, this is my work. I'm doing the work to repair the Buddha's hand finger. Okay, the got damaged with the Buddha's finger. So we use our biocarbonation method to repair this. And also finally we have these three requirements satisfied. The first is just simply say the color difference. The second one is strength. The last one is weather resistance. Actually, we still also have a lot of data, but due to the time limitation, I didn't put here. If anyone interested, I can talk about things. Okay, the third one is the repair of unearthed damaged pottery released using the bioslurry. First, we produce the bioslurry. Bioslurry is the calcium carbonate embedded with bacteria, and that one has very high yield activity. And previously we use this to form a water barrier. You can see the last picture. We have a thin layer formed by the bioslurry. It's very thin, like 3 millimeter. Okay, but they can retain water. The CPG is lower than 10⁻⁹ meters per second. Okay, this is some data, and also I just want to show you the optimal the formula. Get 1.6 mole of the same cementation solution. And also this one, we want to see the durability is nice as under this bioslurry layer undergo the wet and dry process. Also got some, like you can see maybe here is we crack the bioslurry layer and we use the same MICP method to repair the crack. That's what I'm going to talk next. Okay, this is the microstructure analysis. Okay, you can see the original bioslurry is just a loose crystal. Okay, after biocementation, the newly induced calcite fill out the pores and reduce the permeability and forming a dense layer. This is contributed strength and reduce the permeability. This is my study. Okay, repair of damaged pottery remix using bioslurry. First, we got the damaged pottery and we apply the bioslurry on the interface, and then we bond them together, put in the cementation solution, and we soak for like 12 hours. Then we get it repaired. Okay, this is a schematic picture of the whole study. You can see the SEM image. I forgot to change the Chinese. Sorry. The top part is the pottery. The below one is the calcium carbonate, and this dash line is the interface. So we can see the calcium carbonate grow on the interface and connect the damaged part. This, by the way, this is from Ming University. Okay, I got it from somewhere and they asked me to try. And also, we do some CT tests and SEM. This is similar as the previous one. We can see the loose bioslurry after hardened, they got a dense layer, and also we see this CT image after healing. The crack has been sealed. Okay, I also get some tests on the strengths, on the tensile strengths of the bioslurry repaired pottery. Okay, I fix one side and use a weight meter. I drill a hole on this and try to pull. After pull out, we also see the calcium carbonate. We measure the calcium carbonate content is normal. We try to do the soil improvement. I think I got a small video. I think it's 20 seconds plus. Okay, you see the weight meter from 2, 3, 4 kg, 5 kg, 6, 7. Finally, it's like 12 or something. After measuring, after my test, I found out the tensile strength is correlated to the treatment time and precipitated calcium carbonate content, which means like we treat 1 day, 2 day, 3 day, because more as the time increases, the more calcium carbonate can precipitate. Also, the calcium carbonate content is also like related to the strength. As we increase the calcium carbonate content, which means higher strength bonding by the precipitation, and the tensile strength is up to 900 kilopascal. Finally, I move to my conclusion and the future work. Okay, the restoration of sandstone rock carving using biocarbonation method has minor like color difference, got satisfied strength, good weather resistance, and also this is inorganic materials, non-toxic. Okay, I worked with some institute. Okay, they are trying using my biocarbonation method to repair the rock carving. Also, another one is about restoration of damaged pottery remix using bioslurry method. We got good bonding strength, as you can see from the video. And also, it's an inorganic one. We got less aging. Because the precipitation is pure calcium carbonate. Okay, in this we also during repair the pottery remix, we also using this and without introducing extra material, because we only introduce the calcium carbonate, and the original material also contain this. Finally, we improve the durability because it's inorganic one. And the following recommendation can be made for future study. The first is about the long-term weather resistance test. I have done 1 year, but I think I need more time before it can be applied. The second one is we need to improve the working efficiency of bio-slurry method, because now they use a super glue. Although it's very fast, but the thing is the strength is very high. Even the original pottery break again, the glued interface didn't break. This is a problem for them. But for me, they want me to try let it work faster. Okay, they say I need to soak 24 hours. They think it's very long. Okay, the last one is avoid the soaking during treatment, because this pottery remix is easily damaged. Okay, they don't want it to soak that long. Okay, we try use some maybe polymer or something. No. Never mind. That's all my talk. Okay, thank you.